Okay, that's what I'm gonna do on this side too. Oh, just cut it later.
Hello, how are we doing today?
Good.
All right, my name's Laura, and I'm going to be doing a demonstration about liquid nitrogen and the 3 states of matter. But first, I'm going to go over some safety things, safety precautions that I take. I have some goggles here to protect my eyes. I have some gloves to protect my hands because this is negative 321 degrees. I have a lab coat that is a little water resistant, so things will more roll off of this. Unlike my face mask that is cloth and absorbable. If this stuff gets on my face mask, it'll burn through and will absorb through and burn my skin. So you're more than 6 to 10 feet away from me. I'm gonna take this off and put it in my pocket. All right, so who can tell me what they think liquid nitrogen is, or what they know liquid nitrogen is? Any guesses? Yes. It's cold. Yes, it's very cold. It is negative 321 degrees. So our air is mostly made up of nitrogen. The rest is oxygen. 21% is oxygen. There's a few other particles in there as well, but mostly nitrogen and oxygen. So nitrogen is normally a gas, but to make it a liquid, they compress liquid helium with nitrogen and they make liquid nitrogen. Liquid helium is even colder than liquid nitrogen. So let's make some observations, shall we? Put my glasses on. All right. This is kind of a weird liquid. What do you notice? What can you see? It's bubbling. You see gas. Yeah, it's kind of weird, right? Like that. And it turns right back into its gas state. So liquid nitrogen is negative 321 degrees. And this room is about probably 78, 80 degrees. So it creates a really, really large difference in temperature. So it makes liquid nitrogen boil at room temperature. What is this ancient contraption I wield in my hand?
Teapot or whatever?
Yes, a teapot or whatever. Yeah, it's a tea kettle, it's a teapot. What do I need to make this teapot or tea kettle work? What do you need? Heat, yeah, you need a stove. Do I have a stove up here?
No.
You sure?
I don't see it.
Oh, you're questioning now, aren't you? No, I don't have a stove up here, but why is it doing this?
Because it's so cold.
Because it's so cold, it's boiling. So it boils at room temperature because, like I said, it's negative 321 degrees. This room is about 78 to 80 degrees. It's a huge temperature difference. So this room is acting like a giant stove. So I don't need a stove because this stuff just boils at room temperature. If this was a person, if liquid nitrogen was a person, it'd be like, whoa, girl, it's hot. Why do you have me here? What's happening? I'm boiling. And then we boil in our tea kettle. So for my little people, what do our grown-ups tell us when we get too close to the stove? Back away. Do you back away?
Yes.
You do? My 2-year-old does not. At all. But this is a little different. I want you to feel this tea kettle. It's cold, right? Is that like a regular tea kettle? No. It's so cold. Yeah, it's not like a warm tea kettle. We tell you to stay away from the stove. It's cold. It's cold. You good?
It's like,
Yeah, it's really, really, really icy. Huh? Bad girl? You good? Okay. Yeah, so it's different than a tea kettle, right? It's really cold. It's not a hot tea kettle. Still don't touch the stove. But, uninterested. Okay. Perfect. All right. So we saw it escaping, or heard it escaping. Let's do. Uh-oh. I think somebody took my balloon. Oh no. My other balloon has disappeared. I'm gonna try to do it with this one, but this may be a bad idea. But no, it's a regular size balloon, but sometimes we let it go, and then I don't know if I can undo this one actually. Is it pink? No, it is not pink. Are we playing I Spy? Let me see if I can get this one undone, and then we should be good. Sometimes we let it go, and then small children will run on stage and take it, which is fine. All right, let's see if we can get this one to work. It should work. Yeah, this will work. Okay, so let's do a visual of this. What am I doing? Liquid nitrogen. Let's get a little scoop here. Ooh, put that back in my pocket. But before I do that, let's talk about ice cubes. So ice cubes, the particles inside of ice cubes look like this. They're really close together. They're still moving. They move really slowly if they're close together. What happens when we apply heat to an ice cube? What's it do?
expands.
It melts. Those particles look like this. They get a little bit bigger. They're a little more fluid. We know that liquids take on the shape of whatever container they're in. What happens if you keep applying heat to water? What's it do? It boils. And what does that turn into? I guess steam. So steam is the gas form of water. Those particles look like this. They're really big. They can move around. They can escape any room that they're in. What are some other gas particles that can get really big and escape any room that they're in? Any guesses?
Smoke?
Smoke can, yeah. Yeah? Steam, yeah, steam can. Anything else? What's going to happen if I keep letting that go? It's going to pop. Do we want to watch it pop?
Yes.
You sure? Yeah. You just want to see the world burn. All right, let that go. All right, no popping up here, but farts. Farts are another gas that escape. Nobody wants to be around when that methane is expanding and moving wherever it wants to. Yes, that's a bad one. But it exists, and that's what it does. It tries to escape. That's what those particles were doing inside the balloon. They were escaping. They were expanding. They were getting bigger. So, has anyone ever had frozen Pringles? Yes? You know how many kids that tell me they have frozen Pringles? I believe you. Okay, so frozen Pringles. So to make frozen Pringles, some ice cream places will actually use liquid nitrogen to flash freeze ice cream. And then doctors' offices will use liquid nitrogen to remove moles and warts and other stuff that we don't want on our bodies. So we'll put that liquid nitrogen in there, put my lid on. Oh, hold on. Here we go. Try that again. Maybe you're going. We're going to try that one more time. Okay. Go. Okay. All right, one more time. Come on, lid. All right. Put it over here. There we go. Hold on. Ah! It didn't work. Why can't I make frozen Pringles? What's happening? It's all pushing out, yeah. What is it? The gas is escaping, it's expanding, it's getting bigger. And it was all a ruse. There was no Pringles. I just wanted you to understand gas a little bit more, but that's what it was doing. It was expanding, it was building up pressure, and it was making the lid pop up. All right, let's look at it another way. I have, fun fact, all my coworkers here at the Arizona Science Center know how to make balloon animals. I do not. So we will agree that this is a bunny rabbit. Yes? Perfect. Wait, it's a bunny rabbit. All right, what do we think is going to happen to the air particles inside my bunny rabbit when I put it in negative 321 degrees liquid nitrogen?
It's gonna pop.
It's going to pop?
It's gonna freeze.
It's going to freeze? Is that it? Pop or freeze? All right, let's see.
It's gonna shrivel.
So what do you do when you get really cold? Do you run around or do you shrivel up?
Shrivel up.
I shrivel up. Same. You run around? Well, that's one way to get warm, right? But look what happened. It got really cold and it shriveled up. Those particles got really, really close together. But what's happening?
It's melting sort of like water ice.
Oh, that's cool.
It's coming back. It might pop. Those particles are re-expanding. We're gonna put that over there. Sometimes it pops because it gets so cold. But the particles re-expand. They come back, and then we get a snake. So it goes from a rabbit to a snake. But yeah, when they get really cold, they get really, really close together. They get smaller, and they warm up. They came back into the room, and they got bigger. So where can we find liquid nitrogen? Where does it exist naturally? Any guesses? It's a really, really cold place. Yes. Antarctica. Antarctica is really cold, but negative 321 degrees is colder than the coldest day ever recorded in Antarctica. Where's another place that's really, really cold?
I don't know that it's cold, but maybe like a planet.
A planet. Very good. Anybody know the coldest planet?
Oh,
Yeah.
Pluto.
So Pluto is a dwarf planet, but Neptune and Pluto actually do this weird elliptical thing where every 80 years they kind of switch spots. Right now, Pluto is further away than Neptune. Don't quote me on that. But they switch spots. Neptune is the coldest planet. Sometimes Pluto's a little bit colder. They're both really cold places. But Neptune, it's Neptune. Neptune has a moon. The name of the moon is Triton. And on this moon, Triton, it has liquid nitrogen geysers. And they exist right below the surface of that moon. And they look like this. So they just kind of shoot out from the surface. And if we lived there, we could see that. But we don't. We live in Arizona. But where is there a famous geyser? It's not liquid nitrogen, but it's the world's biggest geyser. Yeah. Not in Flagstaff. Wyoming. Not Wyoming. It starts with a C. Yes. California, yeah, Yellowstone. Yellowstone has a really, really big, it's the world's biggest geyser actually, and it didn't go off for a long time. It finally went off in 2017, and when it did, it shot out pacifiers from the 1930s. A very angry 1-year-old threw their pacifier in there 90 years ago. And it also shot out license plates and tires and other stuff. So when you go there, please don't throw stuff into the geyser, but if you do, be prepared for it to shoot back out at you 90 years later. Sometimes that happens. All right, so should we see a really big geyser?
Yeah.
Like Yellowstone? All right, I've been shoveling it in here, so it should be pretty big.
I want to see destruction.
You want to see destruction. You will see destruction. You just got to give me a minute. Ready? Okay, here we go.
Destruction. What? Destruction.
It's kind of dangerous, but it's fine. Here. Okay, that's enough. Not sure if that's water or liquid nitrogen, but it's fine. I'm protected. Okay. All right. Okay. That's enough. All right. So you want to see destruction. So this is my favorite part of the demonstration. I like to go around the Arizona Science Center and try to find things that I can freeze and then break. Would you like to see me break something?
Yeah.
Okay, perfect. I have a ping pong ball. Is anybody in here from a really cold place in the Midwest? No? Just me? Okay. Well, in Missouri, we have ice storms. And ice storms, they make our trees so cold and so heavy with ice and so frozen that our trees will break and fall on our houses. So make sure you have roofer's insurance. But it's very scary because when stuff gets really cold, it can break easier. So we have a ping pong ball. Let's listen to the sound of the ping pong ball. Sorry, you can hear me heavy breathing through this microphone. Now, let's put it in our liquid nitrogen. So like I said, stuff gets really, really cold. It's more brittle. It's easier to break. These electrons holding it together, particles holding it together, they just become not as strong. That's the best way to put it. Okay. Give it 3, 2, 1. Sounds a little different. All right, let's see how easily we can break a ping pong ball. Woo! It worked, and it rings my ears. Yep, and then because these particles will heat up pretty quickly, it will go back to its kind of non-breakable state pretty fast, and then it's just that kind of flexible
That's cool.
rubber. Okay, for the very last part of this demonstration, who can tell me how a cloud is made? How do we make a cloud? Yes?
Evaporation.
Evaporation. It goes into the sky, right? Goes up, you need a little bit of dust. You get a cloud. And then what makes the sound of thunder? What makes thunder so loud? Yeah.
Lightning.
Lightning, yeah. So lightning strikes, it heats up an area super fast, and that abruptness of heat, creates a really loud boom. So what I have is liquid nitrogen that is negative 321 degrees, and then I have boiling water. Oh no. What's gonna happen? What do we think is gonna happen?
It's gonna
Explosion. You think I can maybe make a cloud and a little bit of thunder? Yes? All right, let's try. So we have negative 321 degrees liquid nitrogen. We're going to mix it with boiling water. Water boils at 212 degrees if you're at ocean level. If you are above sea level, if you're at a high elevation of about 7,000 feet or more, water can actually boil at a lower temperature at 198 degrees. So we're going to count down from 10 and see if we can make a cloud and a little bit of thunder. Are we ready?
Yes.
Okay. 10,
9, 8, 7, 6, 5, 4, 3, 2, 1.
All right, you can't complain, the cloud. Thank you for coming to this presentation.